The video you're watching right now edited itself. No timeline, no Premiere, no human dragging clips around. An AI agent read a script, wrote the edit as code, rendered every frame you're seeing, mixed the audio, and burned in these captions. I never opened an editor. In the next few minutes, I'll show you the exact system and why editing on a timeline is about to look as dated as cutting film with a razor blade. Here's the problem. A 10-minute video takes most creators 4 to 8 hours in an editor. Not because the decisions are hard, but because the interface is dragging, trimming, nudging keyframes. Those are mechanical steps a machine should own. The actual creative work, deciding what to say and what to show, takes a fraction of that time. So the fix isn't editing faster. It's deleting the timeline entirely and treating the video as a program that compiles. The architecture has 3 layers. Workflows are instructions written in plain markdown. The steps, the inputs, the definition of done. Agents are the decision makers. Claude Code reads the script, picks the visuals, and writes the scene code. And tools are dumb, deterministic scripts that execute. Text-to-speech, frame rendering, the FFmpeg mix. The AI never touches the render directly. It decides, the tools execute. That split is why the output doesn't drift or hallucinate. Here's the trick that makes this cheap. The AI never watches footage. Watching video means processing millions of tokens of frames. Instead, everything becomes text. The narration is a script. Each visual is a small drawing function. The whole edit decision list fits in a few kilobytes that a model reads in one pass. Hours of output, described in less text than a blog post. That's why this render costs cents while a video editor costs your afternoon. Quality lives in boring rules, enforced every single time. Every audio boundary gets a 30-millisecond fade, so you never hear a pop. Loudness is normalized to -14 LUFS, the level YouTube actually wants. Captions are generated from the same script as the voice, so they can never be out of sync. None of this needs judgment. It needs a machine that never forgets a step. That's what deterministic code gives you that a tired human at 2 a.m. does not. So here's the play. Write your script in plain text. Let an agent turn each section into scene code. Render headlessly with FFmpeg. Version control everything, because your whole video is now just text in a repo. Your first build will be rough. Your 10th will look like this. The tools are free and open, and the barrier is gone. Subscribe if you want the full build, file by file, in the next video. I'll see you in the terminal. Every visual you're watching right now is a small Python function, not a template, not a drag and drop asset. A function that takes the current time and draws nodes, glowing lines, and terminal windows with NumPy and PIL. The agent writes one function per idea, picks which function plays under which sentence, and the render loop calls them in order, frame by frame. Change the function, and the look changes everywhere it's used, instantly. These captions were never typed by hand. They're sliced from the exact same script that became the voiceover, timed proportionally to how long each chunk takes to say, and colored so the important word in each phrase pops in cyan. Because the captions and the audio share one source of truth, they can't fall out of sync the way hand-timed subtitles eventually do on a long video. Raw narration sounds empty, so a procedurally generated ambient bed fills the gaps between sections, a soft synth pad under everything, mixed low enough that it never fights the voice. Loudness gets measured and corrected to -14 LUFS in 2 passes, which is the exact target YouTube normalizes every video to. Skip that step and your audio either sounds quiet next to everyone else or gets turned down and sounds flat. There's no Photoshop file anywhere in this pipeline. The thumbnail is composited in code, bold typography on the left third, a generated focal image on the right third, a thin glowing accent line between them. And for shorts specifically, that exact composited image becomes frame 0 of the video. So whatever YouTube auto grabs as the cover is always the thumbnail we actually designed, never a random freeze frame. Before anything ships, the pipeline verifies itself. It extracts real frames from the rendered file and reads them back to confirm captions actually burned in. It measures the final loudness against the -14 LUFS target, and it greps every caption file for band punctuation that reads as obviously AI written. Nothing gets called done on faith. It gets called done on evidence pulled from the actual output file. This wasn't clean on the first try. Early on, the narration service would silently hang for an hour with 0 output, so every call now has a hard 30-second timeout and retries with backoff. A render once crashed on a broken pipe mid-write, so every frame write is now wrapped, so a drop connection can't kill the whole job. None of this is exotic engineering. It's just handling the boring failure cases so the system runs unattended. Here's the number that matters. A freelance editor charges by the hour, and a polished video like this one easily costs real money in editing time alone. This pipeline runs on local text-to-speech and open-source rendering tools, so the marginal cost of one more video is close to 0. Not because quality doesn't matter, but because the expensive part of editing, the mechanical dragging and trimming, was never where the value lived in the first place. So here's the play. Write your script in plain text. Let an agent turn each section into scene code. Render headlessly with FFmpeg. Version control everything, because your whole video is now just text in a repo. Your first build will be rough. Your 10th will look like this. The tools are free and open, and the barrier is gone. Subscribe if you want the full build, file by file, in the next video. I'll see you in the terminal.